how well the Gaussian model worked. One important feature is that it learns from many collections of face pictures at the same time. It doesn't need millions of training images to work well either. It handled real-world pictures that were blurry, dark, or taken from different angles. It can give either a yes-no answer, which is for binary classifier, or it can give a detailed list of features, which is for feature extractor. It can also it was also more memory efficient and faster at making decisions, which was an improvement called low rank approximation. And most other tools need lots of data, but this one didn't. It got the right answer 98.52% of the time, which was better than the human average of 97.53% on the same test. It reached the score using 200,000 photo pairs. It used the nose, both eyes, and both corners of the mouth as 5 key facial points. And the results for the two modes are 93.73% for binary classifier and 97.79% for feature extractor. So what does this say about AI versus humans? So AI did better on this test. One thing to note is that humans, they don't just use faces to recognize people. We also use voice, body language, memories, things like that. Another thing to note is that the test had its limitations. That is to say, it had photos of strangers' faces, but with no voices or any other extra information of any kind. This shows that AI can do very well on specific niche tasks and jobs. But it doesn't mean that it could replace humans on every task. The Gaussian face shows that an advanced and smart face matching program could be built using the right tools. The Gaussian face learns from many different collections of pictures and uses various tools to tell faces apart quickly and accurately. This is important because it shows that with the right advancements, AI can beat humans at some niche specific tasks. Gaussian face is a big step forward in face verification technology.
Hello, my name is Lelek Sabri, and I'll be going through how the Gaussian face model was built part 2. This slide goes over some of the tools and methods that were used to make the Gaussian face efficient as well as accurate. So to start off with, I will be talking about the anchor graphs. So these help the model to skip unnecessary steps. So instead of comparing every single detail in a huge data set, anchor graphs give it reference points, like shortcuts that still allow for correct results. So this makes the system faster and have a better memory, so more memory efficient. The second one is multitask learning. So this means the model learns many variations of a face all at once. Like how a face looks in different lighting, at different angles, or with different expressions. It also becomes more adaptable and realistic in understanding faces and situations all at once, in different situations. As for discriminative Gaussian process latent variable model, or for short DGPLVM, it helps the system focus on the most important facial differences by mapping face data into a special space where similar faces are grouped closer together, and also different ones are placed farther apart. So this improved model replaces an older one. The older one is GPLVM and does a better job at separating faces that look alike. The improved model is designed to differentiate better between faces due to helping to separate face classes better. So as for how the Gaussian face model works, there are two modes. So the Gaussian face model has two different ways it can work, and it works depending on the task. So as for mode 1, binary, which is binary classifier, this version, which is also called Gaussian face -BC, it gives a simple answer, a yes or no answer. How it does that: first, it breaks faces into small parts, which are called patches, and compares each one, and adding up all of the differences to make a final decision. This is very useful for quick and automatic checks, such as ones at, for example, a security gate. As for mode 2, which is feature extractor, this one is more detailed. Instead of making the final decision, it pulls out the important features from the face and creates something called a feature vector. It also gives a confidence score, which can be passed to another program to help with the final decision. And it's also more flexible and useful in more layered systems, so more complex systems. So it outperformed other models in both of these settings. As for the test used to evaluate the performance, LFW, so this was the only test that was used to evaluate the performance of the Gaussian face model. So to prove how well Gaussian face works, the researchers did use a well-known test called the LFW, which does stand for labeled faces in the wild. So this dataset includes thousands of real-life face photos that were collected from the internet. That means the lighting, facial expressions, and angles are not consistent, and that is a great challenge for face matching programs. Also, the main question of the test is, can the model still say if two different looking photos are still the same person? And that's what makes a dataset valuable. It shows how well the model works in real world situations. So as for the comparison with other tools, so this slide shows how the Gaussian face model performed when compared with 5 common machine learning models. So Gaussian face model was tested against and has outperformed all of these models below. These include the support vector machines, the SVM, the logistic regression, ADA boost, k-means clustering, the Gaussian mixture models. In both of its working modes, Gaussian face outperformed each of these tools on the LFW test. So this is a strong result given how well known and widely used these other methods are. So a big reason for this success was how it was trained. So instead of just learning from one kind of photo, it was trained on several data sets, including the multi-PIE, the morph, the web images, and also live photos. So this variety helped the model avoid being biased and made it more correct when dealing with new and unusual photos. And thank you.